So for this number 11, they want you to sketch it, sine x plus cosine x, and they're saying for x is between there. Hence, find the volume of revolution bounded by x equals 0 and x is pi over 4. So they're just going from 0 to pi over 4. Let's take our calculator then, and we're going to go sine x plus cosine x, sine x, parenthesis, right, plus cosine x. Yeah, that's weird. Why they would say that and go from 0 to pi over 4. Because isn't that what they're saying? I don't get that, but we can do it. That's okay. So let's do it. Let's see it from 0 to pi over 4. So here we go. 0 to pi divided by 4. And I'm still going to go from, negative 3 to 3, just to double check here. And graph it. Huh. So I guess we can just go from 0 to 2 then. Change it from 0. Oh, I like that though. Let's go 0 to 2. It's a little bit more interesting. So we can see that nothing crazy is happening other than that. So we're going to start here at 1, and it's just going to go up to here for pi over 4. It's kind of a nice idea to make a little rectangle here and think of that as spinning around like that. The whole thing is going to be rotated, making like a headlight. That's what the shape is going to be, like a bowl. See if you can set up the volume about the x-axis, going from 0 to pi over 4, I think they're doing. So I get pi going from 0 to pi over 4. The function is sine x plus cosine x, and we're squaring that dx. Okay, so this is going to be pi 0 to pi over 4 of sine squared x plus 2 sine x cosine x plus cosine squared x. That looks horrible. Except what? Something great's going to happen. Susie, do you see it? Say that again. Yeah, we could do 3 integrals. Ooh, I like it. Yes, this could be simplified to sine 2x. I love that. Someone make my life even easier because I don't want to integrate sine squared or cosine squared. Max? Yeah, they add up to 1. Sine squared, if I'm sine squared and you're cosine squared, together we are 1, right? 0 to pi over 4. That's a little shortcut for this one. Now, on the last test, we had this piece to consider. What's your U for this thing? Yeah, would you do me a favor? Would you split this up first? Split it up. I like that. So this is just going to be, yeah, and if you can, U is 2x, du is 2 dx, So we need a 2, pull out a 1/2. So this is going to be pi x plus pi over 2 sine u du. What's that antiderivative going to be? Huh? What's the antiderivative of sine? Negative cosine u times pi over 2. Going from 0 to, what was that, pi over 4. I like working through these. They're kind of interesting. Pi times pi over 4 minus pi over 2 times the cosine of 2 times pi over 4 minus 0 minus 0. I'm not going to even bother with that. So this is going to be pi squared over 4 minus pi over 2. What's the cosine of pi over 2? What's the cosine of pi over 2? Ah, I love it. So it's just going to be pi squared over 4. Is that what they had in the back? Good catch. I went a little too fast here. A little bit too fast. I was hoping pi times 0, that goes to 0. But pi over 2, what's the cosine of 0? 1. So this is minus a minus. This is going to be plus pi over 2. Thank you for catching that. They squared that, though, didn't they? Oh, no, they didn't. No, it looks good. We're good. Thank you. Yeah, watch out for cosine and zeros. The textbooks love to put those in the tests and the final tests because people do exactly what I just did, rush through it. Let's do one. We're going to do 2 of these. We're going to do one around the y-axis, and then I'm going to have you do part B here. So here is the graph. X equal y squared looks like this. And we're going to go from y equal to 1 to y equal to 2. Here to here. So I don't care about this part at all. But what I do care about is that this is the shape that we're going to rotate around the y-axis with a rectangle that's directed this way. So that's kind of interesting. We're rotating this about the y-axis. So we still have these cylinders that look like this. And the volume about the y-axis is still pi, and we're going from 1 to 2 because the y's are determining the starting y, ending y. But what we're going to do here is we're going to have to solve, well, we have solved for x already, so this is going to be y squared squared. Solve for x and go y to y. So just a little solve for x and go from y1 to y2. They gave us y squared, and it's pi r squared height. Yeah. So I bet you could finish that. Pi times y to the 5th over 5, going from 1 to 2, which is just going to be 32/5 pi minus 1 pi over 5, which is, right? 31 pi over 5. Units cubed, because it's a volume. You try Part B. Good luck. True. So when we're looking at this one, the first thing you want to do is to rewrite it as y equal x to the 2/3. But if you're going y here, it means that you're going from y equal to 2 to y equal to 3. So we need to change this so it's x equal to something y. So what's x going to be equal to? If it's x to the 2/3, we're going to get this to x if we take it to the what? 3/2 to both sides. Just take the 3/2 to both sides. Do you see how that cancels? So you get y to the 3/2. And if you graph it, it's going to be what? Something like this. Is that right? Okay, it's curved down. Here and here. Okay, this is x equal to y to the 3/2. Were they being mean by making it to the 3/2? We'll see. So the volume about the y-axis and going from y equal to 2 to 3, I'm going to put y1, y2 here, is still pi going from 2 to 3 of y to the 3/2 squared dy. What's y to the 3/2 squared dy? Right? Right? That was nice of them because now this is just going to be volume about the y-axis, pi, and it's y to the 2/2, or y to the 3rd, dy. So this is going to be pi y to the 4th over 4, going from 2 to 3, which is pi y to the 81/4 minus pi to the 16/4. And I think that simplifies to pi, is that 65? Pi over 4 is your volume about the y-axis going from 2 to 3. 65 pi over 4. 65 pi over 4. Darn it, that's perfect. Wow.